Hello guys, so in our last video we were able to see the static DLLs and the dynamic DLLs, but the problem is that those are like raw data and we can't confirm anything using that. Like if we want to find that like some binaries using dynamic API resolution, then we have to compare the static DLLs to the dynamic DLLs. If those things are doesn't match, that means a binary is using dynamic DLLs. So how we can do that? For that, I will show you a PPT that I made using AI, the Google Notebook. It's I guess now I'm using it a lot. It's fabulous. The thing is like we will create a table, and each table will have the structure, and the structure will define the slot number, and it will have the flags like the if the slot is has been using or not. Sorry, we are using the slot or not. So if it's true that we are using the slot, if not, then we can insert the things inside the slot. So the third thing, we can like put the PID. So this is the main idea we will gonna follow, and let's start then. So to make that table, we have to create a structure here first. So let's create a structure. Type def struct, and we will call it ps snap because we're kind of making a snap here, and sorry, taking a snapshot here. So we will call it handle because first thing we have to add the PID. Another thing is like a boolean flag which will tell that it's in use or not. Now we have to name. I will gonna use small letters because I'm lazy. And another thing is like add a pointer pps snap, and we have created our like structure. So now we have to create a table. We will use the structure snap, and we will call the table, simple as that, and we have to write the size. So it's like size, how many like processes while running you can hold the data. So you can add it like 60, 64. I'm using 128 because I have to test for like bulk things. So let's like start with the define, and let's call it max slot, and max slot. Let's call it let's type here 128, and we will write here max slot. And we created our table. So what we're gonna do, we have to create three function: insert, free, and find. The insert function will add the things in the structure. Free function will remove everything when the process is terminated. Find function will find the PID, and we will gonna see what are the flags we are using or not. So let's start with the first function, which is insert. So let's start with the pointer to our structure, and let's call it insert, and we have to pass the parameter as like process ID. So we have to use a handle, and we call it PID for the variable, and we'll check that if PID is null, then it will return null. And now we will start a loop like u long I is equal to 0, and we will compare to the slot like max slot. It should not be like uh, greater than the max slot. And now we're gonna increment, and now we will gonna check that if a table I in use. So we have to insert. So the table in use flag should be null, means or not null, it should be false. So we're gonna check if it's false. If it false, then we will remove zero the memory. So for that I will use the function rtl zero memory. So it will take the pointer, so I will point to the table I, and another thing, the size. So I will write the size of the table, sorry, structures, which is like ps snap. And by doing this we will like clear the slot everything. So after clearing the slot, we have to like write like add the flag true that we are using it. So we'll start like tab table I in use, and uh, sorry, in use is equal to true. And another thing, we have to write the PID here. Table I PID equal to PID, and we are done here. So before returning, we can log it like log, and we can start with like norm. Uh, we can say slot LU allocated for this PID, and we will write the PID here. And we have to pass things. First thing is slot. Slot should be I because we inside the loop here. And another thing is PID. And so I will write the PID because we passed it. And we will return a table, the pointer to the table, because function demands the, so we are using a pointer here. So function demand function in return wants a pointer too. So we will gonna return it here. So that's it, I guess. So if the loop, if we don't find anything like any free slot, so we can say here a norm no slot is available for PID. That's it. So we're gonna pass it here PID, and we're gonna return null. So we created our first function, so we have to use it before we'll forget. So when we create our process, that's the callback when we get when a process is created. So we're gonna add it here at the bottom. So for that we have to also create a structure. So let's call it PS. It's a pointer, yes, PS snap PS. That's it. So now we will gonna use it here PS and insert, and we will gonna add it a process ID, and we created the thing here. We created the function and we already passed it to the notify, which will give the callback whenever a process is created. So now we have to create a function which will like release the memory. So let's start with the void because we don't want any like in return. So let's copy this here. I don't want to write here. And let's start our function. So copy this, and we're gonna paste it here. So it's a void, so it doesn't matter the sending, so returning a null would be invalid. And same loop we have to do here. So let's copy paste. And now for the if condition that we have to free like free the space using the PID. So instead of searching the PID first, we will search which slot are true, which slot are being used, so that we don't have to like compare the PID with the slot are not like used or not. So let's start with the table I in use. If it's true, then we will compare with the table I with the PID. If it's like equal to PID, then we can say that we can log it out. Before logging out, because we have to clear the memory, so RTL 0 memory, a pointer to the table I, and size of what we say the structure, so it's PS snap. So we are done. Now we can log it out, like log uh, norm and slot emptied for the PID percentage LU, and we have to pass things here. Like we can even define which slot has been emptied. Slot percentage LU is emptied, and let's do it like this. Slot LU is emptied for the PID, that's it. And we have to pass things like I, another thing is PID, and I guess we are done. That's it. It's a void function, so it won't want anything in return. So let's pass it here when the process is terminated, and it's a void, so we don't have to create anything. So let's free mem and process ID, and we are done here. And another thing we have to do, that we have created a table, and when the like driver is loaded, we have to start with it like empty. So RTL 0 memory here, and we will right now we will point to the full table. So table and size of like full table, and almost done, and we are done. So let's check how many errors we're gonna get, and we got any one error here. So what is this? Process spelling is wrong, and very wrong. PROCSSID, and try rebuild it, and bingo, we don't find any error. So we have to delete a previous norm, and we have to create, and let's start. And oh, we make a mistake here. So you can see it will log like every DLL. We have to like comment it out, because it will like show so many data. So we won't be able to manage things. We have to edit it here, process ID, and we are done. Let's rebuild it. Okay, let's delete, stop the EDR, delete. Let's start building it again, and it's done. So let's test and start. Let's go to the debug view, run as administrator, run, and let's open to the notepad. And you can see here the slot 2 allocated for this PID. And if I close this thing, and it will say slot 2 is emptied for same the PID. So bingo, we like did the first step. Now the difficult task starts here. Now what we have to do, we have to save all the static DLLs in the structure, so that whenever uh, a dynamic like DLL runs with the PID, we can compare it with. So for that we have to like uh, make a buffer, so where it can store the DLL name. So I will call it DLL static. Let's call it static DLL name, and I will gonna pass it like two uh, parameters here, not the parameter, the array here. So first thing I will say, like define max DLL, which we can save. Let's call it like 128, because we using 128 already. So define uh, max DLL name, that's it. It will define the name of the, sorry, length of the name. So I will just copy this and paste, and then I will copy this and paste, and we are done. So where we're gonna use this, we will gonna use in the alpha image uh, here. So we have to change so many things of this function so that we can like add things. So let's start one by one. And first of all, let's create a function. Uh, so let's create our function first. So it should be a pps and snap. It should be called like find PID, I guess. And we have to, I will just copy this and paste. Copy and paste. It will be like same thing over and over again. Copy, paste. Is yes, it should return null. And this again, copy and paste here. So now we have to start with the if, like if we have to find the PID, so it should be in use, right? Otherwise we won't able to find. So in use function, here is it. So I will just copy this and paste, and we are done. Now we will just return the table. Sorry, the slot. So return table I, and it should be a pointing to it. So we are done. If it doesn't return, so let's return null. I don't want to write any logs right now. So where we can like add it, we have to write here when, sorry. So instead of using alpha, so we have to do here so many things. So we have to write it here. So let's create pps snap ps, and let's say find a PID and like process ID. And here we can remove this right now because we are using process ID, and we can say if PS is null, then we can just return. So if we are like finding the process ID when the like when the image name will come, we will gonna use it later. So we created our three functions here. One is like insert, free, and find. So we have to save things. The first thing first, we have to save the static DLL first. So for that, where we can see the static DLLs. So this is the part where we see static DLLs. So here we have to add the structure so we can save it in our structure. So I will make this code more professional here. So let's start writing this. And now we have to pass our structure. So it's like pps snap, and I will call it like ps4, like we are using ps only. So that's it. And the thing we have to modify starts from here only. So we have to check that if name is not null, that's a good thing. So another thing we have to check, uh, so we also add another flag in the structure regarding this. So we can add like ulong static count. So it will tell like how many DLLs we are dealing with. So where were we? We were here. So we can say now we have to say like if PS a static uh, count should not greater than the size of the uh, thing here, the max DLL. So that's why we're using the static DLL static count. So it should not greater than the max DLL, and that's it. Everything will run fine. Yes, yes. And another thing, I have to change it like here break. If like I thought about it, like if any bind, if like any DLLs like uh, become that out of the range of the memory, it will just break the loop and we won't be able to see other DLLs. So we have to write it continue here, continue so that we can see every DLLs. So right now we have the structure, everything. Now we have the DLL name here. So what we can do, we can now start copying strncpy. I get this the name, and the first thing should be like ps, and it's like static, it's like static DLL name, and we're gonna add here the static count because that's each count will save the each DLL according to the depth, and that's it. The first thing this, another thing we had to change the pointer. It's like Unicode, we don't want to use Unicode, so we can just use p char here and the DLL name. So we will call it like DLL name, and to the max what we say, so that we can add the null pointer. Where is it? It's like max DLL name minus one. So thing is like max DLL name minus one. So what we are doing actually, we are just copying the static DLL name in our what we say structure, where we can save the name, and each DLL static will like one DLL names, two DLL name, three. So it will like count like this. So we have done it, and now what we can do, we have to add the null pointer here. So we will just copy this and paste here. Another thing, we still have to copy this and paste. Like it does have null pointer just because of the safety purposes. We have to do that, and we are done. So it will save all the DLLs in the static, like all the static DLLs in our structure in this field. So, and another thing, we have to check if the what we say, our static DLL data is ready, because sometimes what happen, some when we can't compare the thing which are not ready. So sometimes when the dynamic DLL runs, it will run before when we can see the static DLL or not. So for that, we have to need a confirmation that static DLL is ready or not. So that's why we are writing another flag here, boolean like static ready. So after doing everything, where is it? Here. So we can write it here like static. Uh, let's write it ps static ready equal to true. So we can, when the function run, we will see that if the static ready is like our static DLL has been saved, and when we can compare, we check this flag that our like we have saved every static DLL correctly. And so what else we are missing? Let me check to the structure. This is done, this is done, this is done. So we can just log it out. Where we can log? We can log it here, I guess. So let's log and we will say norm PID L percentage L. You have percentage L U DLLs. So that's it. We will gonna for the PID we have the structure here. So we will gonna use the structure PID, and another thing for the static count, which we're gonna use PS. Oh, we forgot to like increment the static count. So that's important. Okay, you can't avoid things, and we'll figure out things for hours. So why my code is not working? So PS static count should be incrementing for like each count, and now we will gonna add static count here, and we are done, almost done. I don't think nothing is left. Let's see the structure again. So, and now we will gonna go to the notify image, and we checked. And another thing here we have to see. Okay, parse username mode, save the static DLL, static DLL ready. So these are the things we have to check. This function should not be here. It will be like for the next video. So another thing we have to check that like p image info, right? I guess. So here is a flag called system mode image. So where is it? Where is it? So it will tell us that if the like signal, sorry, if the callback we are getting is coming from like system or from the kernel. If it one, then if it's zero, then it's really coming from the like user mode, a binary which will using exe. So we have to use that for here. Like so, if image, so we can just remove the false data. So the main thing is that we have to find the exe binary. So whenever a binary is executed, the image the run which run first is like exe. So we have to just check that whenever we pass the, so actually what we are doing right now, so whenever a DLL, so for example, I can show you here also. I have the data, right? So you can see here like RTL image directory entry table failed. So why it failed? Because it's parsing the DLLs. So we don't want that. We want that like only exe files like what we say only pass. So that's why what we are doing here. So first of all, we're removing all the kernel level things and the system things. So let's take a thing from here itself, system. So it's if it's true, then we will just gonna return every call, and I will just gonna make it disappear for right now because we have to rewrite everything. So, and now we have, so I also have to check that if binary, so if we have seen the exe, so let's call it like here exe scene for my comfort zone. So I can just see I have seen the exe. And here we are. So what we have done, we find the PID. In the PID, we are just ignoring the system calls. So let's call this function later. We will just, because it doesn't make sense, so I will just call it here. We will just returning null whenever a call, then we will find the PID. After PID, we'll reach to the structure. After the structure, then we have to check that if a PS exe seen, because if this thing happens and we are checking it for null, sorry, so if the thing we are checking is for null, means we didn't even add any flag. So we the first image we're going to see is for exe. So I will just gonna write here. So first of all, I will change the flag. That's what we're gonna do. PS exe scene. So main reason is that we are now passing the exe file. Like I told you, the first image a binary will load is exe. So everything I explained, everything in detail here. So you can see like, because while coding, my whole brain should be like work on code rather than uh, architecture implement. So where is it? I must have wrote it somewhere. Just keep patience, brothers. It's not easy to learn and teach. So I'm not able to find, but it's there. I know my heart say that. If the system executable is removed, even yeah, here is it. The main executable treating the first user mode load image and the executable itself. So that's the thing I was saying. So let's start here and we will put it like true because we have find the first like exe. From everything we gonna pass, like right now, sorry, before we passing it, like every DLL, every callback we are getting. So now we going to pass the first image we'll see when the image loaded according to the PS like the structure. So for that we have everything. Yes. So we have done everything. Now we have to use what we say uh, alpha image and what elpha alpha image, and now we can pass things like image info and what are the things image base, right? It should be image base. Another thing, we have to pass the size image info, and we're gonna pass the size, and another thing is just the what we say, another thing we're gonna pass just the structure. Have we like, yes, we already created the structure, we already stopped the kernel levels symbols, and that's it, I guess. So thing I'm gonna change it here because we won't be able to see things correctly. I will just cut this and paste it after here, and let's check how many errors we will gonna get and paste. And yes, we have two errors here. One error is okay. Another error is process ID, like process ID, and we have to stop the EDR, and let's delete it also. Where is the delete? And let's rebuild it. Okay, it's very amazing that we don't get any errors. So let's create it and start. Let's check our debug view and let's start. Bingo. And now we can see that this like a notepad using 37 DLLs. So it proves that we successfully saved every static DLL in our table. So in our next video, we're gonna like compare the dynamic DLL while it's run to the static DLLs. So if you like this video, I please humbly request you to please like this video, share this video, because I need motivation to make this kind of videos, because learning things is easy. I will just learn and keep everything to myself, but the problem is that I want to make a better EDR for everyone. And another thing is that I want like better EDR which can give the raw data, like when a malware user developer, sorry, when the malware developer use, so they can see how the ADR are flagging their malware. So thank you guys for watching this video.